Good day, students. Today, we want to solve problem under joint variation. When direct variation and inverse variation are combined together, it's referred to as joint variation. And we are going to solve problem under joint variation. Make sure you listen attentively. Okay, now let's see what's on the board. Example, P varies directly as Q. For express that one, P varies directly as Q. That's first part of the question. And also P is inversely as the square of R. There's difference between square roots and square. If you have to look for the square roots, don't take it as square. Square is like when you have R squared, but square roots is square root. We are not in this question. We are not asked to look for inverse of the square root of R, but we have to look for the square of the inverse of the square of R. Now, P varies directly as Q. We have done that. And P also varies inversely as the square of R. Let's try that one also. P varies inversely as the square. Inversely, you have to introduce 1 over square of R. 1 that you introduce shows that it is inverse. Okay, but this is direct based on what explanation tells us. When direct and inverse variation are combined, it is referred to as it is often referred to as joint variation. This is direct variation. This is inverse variation. Inverse variation. To make it joint variation, we bring it together. It should not be in this form. P directly proportional to what? Q, and inversely proportional to the square of R. This is what we refer to as a joint variation. Okay. Now we want to remove the proportionality so that we introduce the constant. Now we have P equals to KQ over R squared. Okay, we are told that if P equals to 1 when Q equals to 8 and R equals to 2, find the value of Q when P equals to 3 and R equals to 5. What you need to do is to get your constant first. Get your constant. We are told that P, when P equals to 1, Q equals to 8, R equals to 2. Do you know constant? K. K is unknown. We have to look for it. Now let's substitute our value. P 1 is 1, K unknown, times Q 8 over R squared, 2 squared. Is that clear? Now 1 equals 8K over K times 8 is 8K, 2 squared is 4. Okay, now let's cross multiply. When you cross multiply, you have 8K to be equals to 4 times 1. Okay, you have 8K equals to 4. Divide both sides. Divide both sides by 8 so that we can get our K. You have 8K over 8 equals 4 over 8. 8 cancel 8. 1 8 here 1. 4 year 1, 4 year 2. Our k now equals half. Our k is half. Now we can go back and substitute the value of k so that we can get the relation of the equation, because sometimes you might be asked in theory to look for the relation. Let's see the relation. Relation goes thus: go back, write your p, put your p down. What's our k? K is half. Q, you put your q is only the k you substitute over r squared, which is equal to 1 times q over 2r squared. Now therefore p equals q over 2r squared. Now put in bracket, write relation. This is the relation. Okay, now let's now go back to the question. Then I'll say find the value of q when p equals to 3 and r equals to 5. Now say from here you can make q the subject of the formula. Q equals to 2pr squared. Okay, we have to look for, find the value of q. Q is unknown, p is 3, and r equals to 5. Now let's look for our q. Q now equals 2 times, let's substitute, times 3 times r 5 squared, which is equals to 2 times 3 6 times 5 times 5 squared means 5 times 5, which is 25. Okay, now let's do the multiplication. When you multiply 25 times 6, 6 times 5, 30, 0, carry 3, 6 times 2, 12, plus 3, 15. Okay, therefore our q equals 150. Okay, our q is 150. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.